In this lesson, we're going to take a look at electrons. I mentioned earlier that electrons are important in chemical bonds and they help determine the properties of elements. And the reason they determine the properties of elements is because of their role in bonding. So we're talking chemical properties, or how these elements, how these atoms are going to interact with other atoms. So electrons are found in energy levels around the nucleus. So the nucleus is a very positive region in the center of the atom. It's very, very dense. It's also very, very small. If the atom were the size of a football stadium, the nucleus would be about the size of a marble, and it would be in the middle, and electrons would be out by the lights. So electrons are way out here, but they're not all in one spot. They're not all the same distance from the nucleus. Some of them are closer to the nucleus and some of them are further away. And the distance is sort of related to the energy levels. The closer it is to the nucleus, the lower the energy level. So as we get closer, this is less energy, and that makes sense because electrons want to fall towards positive charge. Just like heavy things want to fall to the earth, negative things want to fall towards positive. So as they get closer and closer, they have less energy, and as they get further away, they have more energy. This is kind of the energy, this is sort of related to chemical potential energy then. And so these electrons are floating around in energy levels. As you get further from the nucleus, there's more of them. Okay? So the first energy level is fairly close, but it can only hold 2 electrons. The next energy level is out here. It can hold 8 electrons. The next energy level is out here, and it can hold 18 electrons. And in fact, there's a pattern to this, 2n squared, where n is your energy level. So further away, more electrons, and they have higher energy. The electrons on the outside are the ones that we care about, and we call those valence electrons. These are in the outermost occupied energy level. So even though every atom theoretically has an infinite number of energy levels out here, they're not all occupied because electrons are attracted to the nucleus. They're only going to occupy the first, generally 7 or so energy levels, and for smaller atoms, maybe only the first 3. Okay, so valence electrons are the ones in the outer energy level, and those are the ones that are available to do things. They're involved in bonding and reactions, because bonding happens when electrons are shared or transferred between atoms, and that happens on the outside. Now, on the periodic table, atoms in the same group have similar properties because they have the same number of valence electrons. And atoms in a period have changing properties because they have different numbers of valence electrons. And we're going to take a look at that on the periodic table in just a minute. Okay? Now, the one thing to keep in mind with valence electrons is they follow the octet rule, or at least most things do. Oct is 8. So elements, carbon and larger, are stable with 8 valence electrons. So if they have 8 of them in their outermost layer, in their outermost energy level, they're going to be stable. They're not going to want to form any more bonds or change very much because they do have a stable electron configuration. For smaller ones, it's 2, and that's because that energy level, the first one, only holds 2 electrons. So if we take a look on the periodic table, can we identify which group is stable? Sure we can. Here's the periodic table of the elements. We have group 1A, then we have group 2A, then we have all of these groups, which are called the B groups, and we're not going to look too much at those. Whoops, what just happened? The B groups, we'll look more at those later, and then I have 3A, 4A, 5A, 6A, 7A. Now, we mentioned last time atomic number is the number of protons. There's 1, there's 2, right? And so this has 1 electron, 2 electrons, 3 protons, which also means 3 electrons. It started over in a new row because those electrons are now starting over in a new energy level. So this has 2, it's a small one, it's stable at 2. And then we have 3, 4, 5, 6, 7, 8, 9, 10. So this is atomic number 10, which means 10 protons. And it has 8 valence electrons. 8 valence electrons because 2 of them are in the first energy level, and the next 8 are in the next energy level. So we get to neon, and it's stable. And that pattern repeats over and over. We'll get more into how electrons fill in energy levels later in chemistry, but for now we can look at the periodic table and we can see anything over here has 8 valence electrons. Anything in this column has 7, 6, 5, and that's why these get these numbers. Okay? So the A group number tells me the number of valence electrons. Everything in column 1 has 1 valence electron. Everything in column 2A, 2 valence electrons, 3A, 3 valence electrons, and so on. So by looking at something on the periodic table, you can tell me how many valence electrons it has. Iodine has 7 valence electrons. In fact, everything in this column has 7 valence electrons, and it turns out the closer an element is to having the full shell, the full 8, the more reactive it is. So fluorine, very, very reactive. Lithium is also very reactive, and that's because it's only 1 extra, right? It's got a full energy level with its 2, and then it's got 1 out here, and it can get rid of that, and it could drop down to having a full shell. So first column, very reactive. Those are the alkali metals. Last column, very reactive. Those are the halogens. The stuff in between tends to have intermediate activities or reactivities.